Let's solve another question. Now this question can be obtained using second theorem. And if you look very well, you see that this theorem, these two questions can be obtained using a particular theorem. And that theorem states that angle in the same segments are equal. Or you can state the theorem as angle subtended by the same chord are equal. So now look at it. Where is the chord? Now you may want to ask the question. Now if you see this type of question, just introduce your chord. Now this is the chord. This is the chord. Now that is the chord. Now this angle, let's call this one A, and here is B, and here is C, and here is D. Now look at it. You will discover that this chord that subtends this angle is the same chord that subtends this angle. That is angle ABC is equal to angle ADC. You see the chord, this chord and this two chord. Now they subtend this angle, which is 48 degrees, and D. So therefore D is equal to 48 degrees. What is the reason? Angles in the same segments are equal. That's the reason for the answer. Now let's solve question B. This is question A. Now let's solve question B. Can we still apply the same concept in solving this problem? Yes, we can still apply the same concept. Here we are looking for angle B and angle C. Now there's one striking thing that you must note, is that these two lines, they are the diameter because they pass through the center of the circle. So what do we do in getting the answer? Now first thing first is to state that B is equal to 33 degrees because they are subtended by this chord. Okay, so I have formed, invariably I have formed a right angle triangle. So here is 90 degrees. 90 degrees. It means that if I know here to be 90